Welcome to this brief introduction to R, where we'll learn how to use R as a calculator and how to put in variables and how to use functions and how to load in data for basic statistical analysis. R is a free programming language environment for statistical analysis and graphics. While following this tutorial, it will be advisable to have the program open so you try the codes along. To see how to download and install R, watch our first video. I wrongly thought I would never be able to learn R since I had no programming knowledge, but then I eventually stumbled several times and learned R as an end user. The aim of this video will be to help you avoid the stumbling blocks and learn R fast as a casual end user for basic analysis. Well, you may be thinking programming is not your thing. No panic. You can learn R for data analysis without being a programmer. When you start R, you will see this text here describing the program. What is important for you is this sign, which is flashing with a cursor, and this greater than sign. It is called the command prompt. The best way to get familiar with R is to use it as a calculator, since you already have calculators, and it's a powerful calculator. You could type onto the R console directly and hit enter to run your code. We introduced Arrow scripts and Arrow Studio in the last video, but we'll not use them much for now. So let's start by doing some arithmetic. We could start, for instance, by adding 3 plus 7, and when we hit enter, the answer 10 comes up. Notice this one in the square brackets on the left side of the answer. An easy way of thinking of it is like imagining we have asked the program a question which it evaluates and holds the answer in its memory. When you hit enter, it returns the answer. In programming language, R takes the input, evaluates it, and creates one object holding the answer. If we were to type 3 plus and hit enter without finishing, R will produce a plus sign on the next line. This is like saying the code is not yet complete and it's waiting for us to input one other thing for it to be complete. So we may now add 8 to finish the operation and hit enter, and we'll still have our answer. R is also a programming language. We can also enter text in R. For instance, the canonical first code in many programming languages print hello world. So we go print, enter, and there we have the answer. So this text is part of the programming code and will be evaluated by the program. We can also enter text in the form of notes, which will not be evaluated by the program. And this is important for us to keep track with what we are doing in the program. The sequences of codes in programming languages can be very daunting and boring and are best read by machines. It is a good idea to make notes to explain in human language what the program is doing. These notes are called comments in programming languages. For R, they start with a pound sign. Once you write pound, everything to the right of the pound do not get evaluated. It is ignored. This way, you can make your own notes within codes. So going forward, let's continue and also use comments to explain. Note that when it comes to figures, R is tolerant of spacing. For instance, 3 plus 7, and we now put our comment in there. So notice that this is a comment, and as we explained before, everything behind this pound sign will not be evaluated. So 3 plus 7, we hit enter, the answer is 10. And this will be the same like we take 3 plus 7, and let's put our notes here. Despite the spaces, arrow still evaluates the same. So we hit enter and the answer is 10. So R is tolerant with spaces when it comes to figures or numbers. But if we want to take, say, the square root of 9, we will use a function. So a function to take the square root of 9 is sqrt and 9 in brackets. We hit enter and we have 3. A function is a named sequence of statements that will perform a calculation or computation. Therefore, sqrt, bracket open and close here, is a function. Now, if we were to take sqrt and notice the space here and bracket open 9 and we hit enter, we're going to have an error message error unexpected symbol in sqrt. And this is because R is not very tolerant of spaces when it comes to letters. So the take-home message is that we have to be careful when typing. So while using R, error messages will pop up now and then. As an end user, a casual end user, it may be difficult to exactly understand what they mean. The best thing to do is just to go back to your code and see what wrong thing you did and correct it before moving forward. We can also do calculations using the usual arithmetic operations we have learned in school. When doing arithmetic operations, the order of operations matter. In school, we learn about BODMAS or BEDMAS, and BODMAS will be bracket first, orders, division and multiplication, addition and subtraction from left to right. Or BEDMAS will be bracket first, exponents, division and multiplication, addition and subtraction. So let's try by doing a calculation. If we were to take 10 plus brackets 3 times 5 exponential 2 plus 4 minus 2 bracket close. If we were to hit enter, we'll notice that we get an error message. So we go enter, and you have to notice here that the sign for the operations are a little bit different from what you know. So here the problem is that we didn't use the right sign for multiplication. So this is the point for us to learn about how to copy a previous code. And to copy a previous code, you use the arrow key up on the right hand of your computer and go one step up. So right now we have our previous operation, and we can use the arrow left head key to go to where we had our error. We delete it and we put the right sign for multiplication. And when we hit enter, we now have our answer. This brings us to variables. A variable is a name that refers to a value. We can assign variables using the less than and minus sign or the equal to sign. So you will choose which one is better for you. They can be used interchangeably in R. For example, we may say x is equal to 5, y is equal to 3, and we can then take x multiplied by y, and we have the answer, which is 15. We can also say x plus y, hit enter, and we have the answer, which is 8. We could have assigned the output of this operation to another variable. For instance, we could have said z is equal to x plus y, and we hit enter. And then we can go on to ask what is z by just typing z in and hit enter, and we have the answer. How to name variables? We can use A to Z, upper or lower case, and this is case sensitive. We can use 0 to 9, so alphanumeric. We can use underscore. We can use full stop or the period. We can only begin with a letter or a full stop or period. And we have to avoid reserved words. Programming languages have reserved words and signs. And to know the reserved words in R, we go in here and type question mark reserved, and we hit enter. It's going to evaluate that, and it will open a web browser showing us the reserved words. And in this case, we have some documentation for the reserved words of R. So you could go in there, read them, if, else, repeat, while, etc., true, false, and all the like. We may not use those to name variables. Reserved words are words that have special meaning to a programming language, R in this case. When R sees these words in a program, they mean only one thing to it. Indeed, the variables we have been making are our own kind of special words made to be used for the moment. You have the flexibility to choose words for names of variables, but you may never and never use the reserved words of a programming language. We now move on to functions. We've seen and we've used a function before, which is the sqrt function for square root. We have used also before arithmetic operators to do calculations, but we will not be repeating same sequences of events for any new numbers that come up. Programming languages have clever ways of letting us avoid repetitive tasks. In programming, a function is a named sequence of logical statements that perform a computation. The creators of R have written many built-in functions for you, specifying their names and sequence of events they should do. when you use a function, you call it by name. The sqrt we saw before is the name of a function that takes square roots of numbers placed in brackets after the function call. Later, if you become more experienced, you could write functions yourself. Let's see again the square root function. So if we take sqrt 9, we have the square root of, so I have an error message there because I typed 2t, sorry. sqrt 9, we have the square root of 9, and I copy that and replace 9 by 64, hit enter, and we have 8. We see how generic functions are and how they make life easy. We do not have to write out the formula for square root each time. Other quick functions in alphabetical order will be the absolute, and if we take absolute minus 8, enter, we have 8. Another one will be the round. So if we round 4.12345, it gives us 4. So this gives us a nice possibility to define what arguments are. The argument is a value or variable that we are passing into functions as input. So if we take round 4.12345, then the value inside here is a variable. So if we take round 4.12345, then the value inside here is part of an argument. So when we write round 4.12345, we are using the arguments in their default. So actually we could have written, for instance, round 4.12345, comma 2, and enter, and we see that we have now 4.12. So we are having 2 decimal places included. So here there are 2 arguments. This first one is to be rounded, and this second one gives the number of digits the program should round to. So we actually could have written this function in this way by saying round, and we go x is equal to 4.12345 and digits is equal to 2. And if we hit enter, we have the same kind of answer. To get some little bit of variability, so let's copy that and change here to 4 decimal places, hit enter, and we see what answer it gives. Now that we've come to know what functions are, we will learn how to read in data into R using some functions. You can only begin analysis after reading in data. We have been typing things directly into the R console. However, to have your scripts organized, you will have to go to File, New Script, and you're going to have this window that opens, and you can go up to Window and tile either horizontally or vertically. If you tile vertically, a new arrow editor will appear on the left and your console will appear on the right. You can now type in your command in here in the script and go to run to have it translated into the console. So let's continue to use this now for a bit so we get used to scripts. First, we want to know what a vector is. A vector is a sequence of data elements of same basic type. Members in a vector are officially called components. We use this here just as an example. We will not go into details about vectors. So to create a vector using the numbers 1 to 10, we'll go the following way. We say my.vector is equal to C. C stands for combine or concatenate, and in brackets 1:10, so 1 to 10. And if we put the cursor here and go to run, we'll see it here down on our console. We have seen functions before, so some more functions now. Now that we have a vector, we can use some functions to have some analysis about what is inside. So we can go length, my vector, and when we go run, we see the length is 10. There are 10 elements inside. So we could just copy this and edit it for the next line. So here, instead of length, I put min, and we could paste again and put SD for standard deviation, SD, and paste again and put var for variance. So VAR. So before we had to put the cursor in front here and went to run to evaluate it to get 10 elements in the vector. If you have a script, a quicker way of doing it is to select everything and then go to run, and you notice here that each of them has been evaluated, beginning from the standard, the mean, the standard deviation, and the variance. So the last function we will use is the summary function. So here I paste again and I write here summary. And if we evaluate this, we're going to have a summary of the data elements in our vector, showing from the minimum to the median, the mean, and the maximum. When working with the script as we are doing right now, the console may become very populated. To clear the console so that we begin from a blank slate, we take Ctrl L. And we can decide now to save the script, just like we will save every normal editor, and we could call it up anytime for use. Now, when you get used to analyzing data in R, you will realize that it will be easier for you to do things as scripts. This comes in handy, for instance, if you ask a question to a collaborator who may then look at your data and write some scripts for you which you can evaluate in R. Now that we have seen how scripts work, I'm going to close all of this all together and open the R console again so that we all have the same kind of console. There are definitely many ways of importing data into R, but here I will show just the simplest for the first time end user. Later, you may look around for other more complicated and effective ways of doing the same thing. What we'll use in the next video is a very simple one that copies data from a clipboard. So we use a new function for reading in data into R, and here we will say my.data is equal to read.table, brackets, inverted commas, open and close, and we say clipboard, and we go here comma, and we say header is equal to true, or we just can say h is equal to t. So what this does is that it reads the data that has been saved onto the clipboard. The clipboard is a temporal storage area when you copy data from programs. So we go to Excel file, which we've been using. We have data here from 3 sites, from Control, Limbeck, and Bamenda. And this is the way the human eye would like to read it, but you arrange it this way to load it into R, and by having an X factor and a Y variable. So if you copy this now, highlight it and take Ctrl C, and you go back to your R console where the command is, and you hit enter, you're going to see that the data has been loaded into R. So if we go now, my.data, enter, we see that we've loaded everything into R. So I have further files here with different formats, which we have seen in class. CSV is one of them, and text, plain text is one of them. So another way of reading in data is using the same kind of code like we used before, but in the place of clipboard, we are writing in the file path where the path is found. And since we are not computer programmers and we are not very savvy, the best way to do that is to grab a file, like in this case we have this worms file here, which is a CSV file. You grab it and pull it onto R. It's going to produce an error message, but that is not what is important for us. What is important is the fact that we can copy this path here, which is the path where our data is found. So using the arrowhead up key on the keyboard, we could go previously to the last script we use, and we could replace clipboard here by that path we just copied, and let's call this one my data 1, just to have a difference. So if we hit enter, we'll notice that that has been loaded into our computer. So if we go my.data 1, we have the same thing showing, but this is showing like CSV files. So this is basically the same like before, but as CSV file, because we have here worms.csv, which is the file type we have here. So the next one we're going to look at is this text file, and we'll want to read the data directly into R, and the third possibility of reading that is first of all to go here to file, and then you say change directory, and you point the computer to where your file is found. In this case it's on the desktop, and then I go enter. And right now if we use this code, so I copy the previous codes and change it. So in place of this path here, we're just going to put the name of the file, and here we'll say worms.txt, which is the type of a file, and let's call this my.data2. So if we hit enter, we'll notice that that has been loaded into R, and if we ask here what is my.data2, we have it showing in here. Notice here that in this code, instead of having worms.txt, we could have had worms.csv if we wanted to have this file in worms.xls or any other file format we wish to use. So in this video, I've deliberately skipped hints on logical operators, details on data types like vectors, data frames, matrices, etc. As we say in West Africa, we'll cross those rivers when we get there. In the next video, we'll begin using some functions and codes to do real statistics with R. Thank you for watching our video. Please give us a thumbs up below or leave your comments below. See you in the next video.